Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SAS guesswork and SQL gruntwork out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/RudderStack. You shouldn't have to throw away the database to build with fast-changing data. You should be able to keep the familiarity of SQL and the proven architecture of cloud warehouses, but swap the decades-old batch computation model for an efficient incremental engine to get complex queries that are always up to date. With Materialize, you can. It's the only true SQL streaming database built from the ground up to meet the needs of modern data products. Whether it's real-time dashboarding and analytics, personalization and segmentation, or automation and alerting, Materialize gives you the ability to work with fresh, correct, and scalable results, all on a familiar SQL interface. Go to dataengineeringpodcast.com/materialize today to get 2 weeks free. Your host is Tobias Macey, and today I'm welcoming back Nick Schrock to talk about the state of the ecosystem for data orchestration. So, Nick, for people who haven't heard you on any of your past appearances, can you just give a quick introduction?
Sure. Thanks for having me, Tobias. My name is Nick Schrock. I'm the CTO and founder of Elemental, the company behind Dagster. And before Dagster, I was best known as one of the co-creators of GraphQL. And yeah, founded Elemental in kind of incorporated in 2018, and the company really got going in 2019 and been building that ever since.
And do you remember how you first got started working in data?
Yeah, I mean, I think we can start in terms of, it became the bulk of my career at Facebook was dealing with our data fetching stack for our application developers, and that was naturally kind of data management adjacent. But when I really went kind of head first into it was, when I left Facebook, I was figuring out what to do next. And I kept on talking to all these companies, both inside and outside the valley. And data infrastructure, ML infrastructure just kept on coming up over and over again as the biggest technical liability that they were facing. They couldn't get engineers to work on it. All the developer workflows are completely broken. It felt like going back in time relative to other software engineering domains, et cetera, et cetera. And then, kind of started to look into it, and I was hooked because it shared a bunch of the properties that I'm really interested in. One, I was kind of I knew about data management issues and I was adjacent to it at Facebook, but it was like a domain where like the engineers were absolutely in pain. That really personally motivated to me. It's a huge horizontal market. I really like working on projects where there's potentially hundreds of thousands and millions of users and developers. I get a lot of energy from that. And then orchestration in particular was this really interesting strategic point of leverage in that stack because the orchestrator kind of invokes every runtime, which touches every storage engine, and every single practitioner who's putting a data asset or pipeline into production generally has to interact with orchestration because all data comes from somewhere and goes somewhere. And and then in the end, like this was also a problem that really mattered. These data platforms at these companies drive extraordinarily important societal processes. ML systems determine who gets loans and not, how we price healthcare, you know, all these absolutely essential functions of society. And I think it's like incredibly important that it's all built on solid engineering principles and that the ecosystem is compounding and moving forward. So that was kind of the background of how we got into this.
And so, in terms of data orchestration, we've already mentioned that term a few times. The idea of orchestration is very abstract, exists in a number of different venues and instances. And for the purpose of this conversation, I'd like to just get a shared understanding of what we mean when we talk about data orchestration and how that differs from other types of orchestrators that people might be experiencing, particularly thinking things like container orchestration, generalized workflow orchestration, things like that.
Yeah, that's a great question. I mean, at some level in computing, all orchestration is doing in all of these domains is spinning up compute and then spinning it down. for the purpose of achieving some sort of outcome or goal. Typically, container orchestration, and I think the kind of standardized things people think of when they think of container orchestration is K8s. And typically that's used to spin up compute to run a service or just to run raw compute. That's generally what it's used for. We at Dagster, we build on K8s to build a lot of our services. In terms of data orchestration, you are still generally spinning up compute, but it is in service of a goal that's more specialized than container orchestration. And that goal in this case is to orchestrate how data is managed in your platform. All data at some level is produced by computation, right? So from the standpoint of a company, they have input data, which is typically data inputted by a user, crawled from an external system outside of their control, maybe generated by a sensor. Every single other data artifact that's managed by the system is derived from those raw sources and produced by compute. And the data, both the size and well, not necessarily the size, but certainly the number of different tables is dominated by these derived data artifacts in the system. Like companies have like hundreds of thousands of these things, and that has to be managed. And the data orchestration system is responsible for scheduling the computations that produce all those derived data sets and data assets, and spinning up the compute to do it. So to summarize, like all the orchestration variants in technology are generally about orchestrating compute. Then it's a question of to what end and what specialized features do you need for that.
Yeah, and what are the things that the orchestrators are paying attention to? So in data orchestration, you are ideally focused on what are the aspects of the data that you're trying to work through, what are the operations that you're trying to do on it, and what information does the orchestrator need to have to be able to effectively drive the state machine of that workflow, versus a generalized compute orchestrator like Kubernetes that needs to be aware of what are all of the hardware capabilities of the system, what are the resources that you're trying to request from it, what are the scheduling aspects of when this particular unit of compute needs to be executing for how long and under what failure modes. And for the data orchestrator, what are the failure modes of data and how much does the orchestrator need to know about that to help the end consumer of that orchestration make sure that they are on top of what those failures are and resolving them. And so in terms of the adoption of data orchestration, as somebody who's been working in this space I looked in the Git history, and it's been 5 years now since you first started working on Dagster, a little bit less than that since it was generally public and in use. But what are some of the misconceptions that you've come across in terms of the applications of, the need for, and the cost to implement data orchestration as you've worked with people who are consumers of Dagster or who are evaluating the overall space?
Yeah, I think that the one big misconception, which still exists, and we still have work to do to educate the market on this, and I think we're going to get into this, is that everyone needs orchestration. And right now, I think the mental position of practitioner is that bringing in an orchestration layer is something you do kind of late in the development of a data platform. And I think in reality, you need to be thinking about orchestration from day one. And because people don't bring in broad-based orchestration layers until too late, it often becomes this like kind of adoption struggle, and you need to retrofit your systems to slot into it. But what happens is that, especially in the modern data stack world, people spin up all these point solutions that all have their little baby orchestrators inside of them, and they're running overlapping cron jobs. So you might have like a cron job running in Airbyte, one running in dbt cloud, one running in Snowflake, one running in high touch, whatever solutions. Then you're left with this Rube Goldberg machine where you don't have anything, no idea what's going on. And then only later at a great cost do you bring an orchestrator to kind of unify all that together. I think the ecosystem would serve, and I'm an orchestration vendor, so this sounds self-centered, but and self-serving. But I genuinely believe it's true that the ecosystem and the practitioners would be far better served if they viewed the orchestrator as kind of one of the first tools they bring in when they start building their data pipelines, as opposed to sort of after the fact thing. I think that's partially on us to make that more obvious and kind of bring it farther left in the adoption curve. It's just kind of like how you can't make something secure after the fact. It's like much more costly to do after the fact. It just makes sense to kind of start with this foundation and have a unified view of like all your data processes from day one. It just makes your life so much easier.
Another interesting aspect of that is the conversations with people who already have some form of orchestration in place, particularly if they say, oh, I've already got Kubernetes, or oh, I've already got a CI/CD system. Why do I need something like Dagster or Prefect or Airflow or whatever it is? I've already got a way to make sure all these things are running. I may even have some way of backing in some useful triggers of the data aspects that I care about. Why do I need a dedicated system just for that when I've already got an orchestrator or I've already got a workflow engine?
Yeah, I mean, it kind of depends on what you're what you're looking for and what your problems are. But I would just start asking questions about like, okay, how do we test all this stuff? Once there's an issue, like let's go through your debugging workflow. Let's say you have two different data engineers or two different practitioners in your system who are trying to interrelate what each other are doing. What's going on? How do you track the lineage of your data going through the system? How do you track the metadata of all your data assets? How do you alert off of that? There's just an entire set of capabilities that entire set of capabilities don't exist. I guess like, just in a kind of an emotional level, I feel like if you just have some cron job running using like Kate's native cron job or something, just as a throw out like a kind of one of the baby orchestrators, you kind of feel like you're treading water and things work, but then once things start going wrong, it becomes very difficult. And it's very difficult as well to kind of have a single place where you can organize your entire beta platform and know what's going on. So, I mean, part of this is like the existing problems that you have. But the other thing is that, once you kind of are in a world with a more sophisticated orchestration system that gives you this like so-called single pane of glass, it's really kind of hard to go back. You're like, how did I operate without having this?
Absolutely. Yeah, from personal experience, I've definitely had conversations with somebody who said, oh, I've already got a Singer Tap and Target running in Jenkins. Why do I need something more than that? Or why do I need to bring in something like an Airflow or a Dagster? I've already got Argo CD that I can use to define these chains.
I mean, and also part of it is what are your needs, right? It's kind of, someone like if someone's just running Jenkins and wants to do one thing and that's all they want to do and it works fine, that works for them in the same way that like someone can write a web page using HTML if they just want to display some static content. They don't need to bring in a modern front end framework. But if you want to have like a more modern experience, and do more sophisticated things that in today's world there's table stakes, like you generally need to bring in a framework to help you out.
Absolutely. For the requirements gathering and evaluation of these frameworks, data is very multifaceted in nature, largely because of the different personas and stakeholders involved, not even necessarily just from the technical aspects. It's largely the organizational and socio-technical aspects that really make it complex. And I'm wondering what you see as the interfaces that are necessary to be able to properly support the various needs of different stakeholders in being able to work with, gain visibility into, and understand the applications of data in that socio-technical framework.
Yeah, this is a great question, actually something that is super top of mind for me because you're kind of maybe I might start repurposing some of your language for our this internal roadmap document I'm working on. But internally, what we talk about a lot is that in these data platform teams, because a ton of our users describe themselves either as data platform engineers or they're data engineers who work on data platform teams. So, and that set of users, that champion, is just thinking in terms of stakeholders all the time because that's their life. Their entire job is to scale data engineering across an organization. And I think what we're really learning here and what we have to, and what we're actively working on is making it so that central driving data platform team can incorporate their stakeholders into the Dagster ecosystem with as minimum of code changes as possible. You know, like I think we have this pretty well dialed with our DBT integration, for example, where a data platform team can come in, implement Dagster Cloud, and then kind of import the existing DBT project that the analytics engineer is working on, and their workflow isn't disrupted, we can import their graph, view it natively in our system, and then that analytics engineer working on DBT doesn't have to disrupt their workflow, but they can get a bunch of value out of the tool because they can view the graph there and all their data lineage and the way it interlaces between systems. And then the data platform team gets a bunch of value because they've consolidated the control plane of their data platform onto one system. And I think we need to replicate that dynamic across a bunch of things. Right now, what we've learned is that we often get into a situation where the centralized team is super excited about Dagster. They're willing to invest the time to really get up to speed in the system. But then the prospect of them kind of teaching the rest of their stakeholders to also be deeper users is just a bridge too far. And so we're really thinking about dividing our use case into this champion persona and the stakeholder persona. And they have different needs from the programming model and the tool.
As I mentioned earlier, you've been working on Dagster for 5 years now, give or take. At that time, Airflow was definitely the predominant orchestrator that people were talking about. It still is one of the largest players in the space. I'm wondering, over that time period, how you have seen the requirements and adoption and application of orchestrators change.
Yeah, this is a super broad question. I guess it's worth talking about all the things that have happened. So since 2018, there's obviously been kind of a new generation of orchestrators and tools that have cropped up. So, Airflow still exists and they've been making progress, and there's still definitely like the kind of largest incumbent. But what hasn't changed is that in 2018, Airflow was something that people lived with but did not love. And I still think that's true today, by and large. So it's kind of this like it does its job, but it doesn't feel like a complete solution, and it doesn't have a great developer workflow and all this stuff. And so I think everyone has realized this, and there's kind of like new crop of successors that have popped up kind of vying for their place. And I think the primary ones you can think about are Dagster, there's Prefect, and I also categorize, DBT Cloud especially as just as another entrant in the orchestration space, even though kind of traditionally it's not thought of. There's also an entire there's another kind of family of tools that we can get into too, which is these vertically integrated ML ops platforms that usually have a orchestration system baked into them. And lastly, the people vying for be the successor to core orchestration, there's the ML ops platforms. And then there's people who just kind of assemble orchestration systems out of these point solutions where they all have their little baby cron jobs. In terms of how and again, for the audience, they're like, okay, the Dagster guy is going to now, talk his book and talk about Dagster. But I will attempt to put on like my analyst hat and try to be as objective as possible here. I'll talk about the core orchestration kind of domain first. I think what's interesting is that Airflow, Dagster, and Prefect, say in 2019, 2020, each system had its kind of unique value proposition that it was claiming. But in the end, they actually, from a certain point of view, had similar concepts. They were all orchestrating DAGs of tasks, building a DAG of task, a DAG of computation with Python and running it, right? And we all had our different take on that. And then, what happened in late 2020 to 22 is that both Prefect and Dagster went two kind of different ways from Airflow, and like the category transformed from kind of like three people who were claiming like, hey, we're the best way to orchestrate DAGs of tasks, instead went their own separate way. And Airflow kind of stayed the course, right? They are still, we build workflows with Python. Prefect, they called it Orion, but it's now Prefect V2. They went a completely different direction. They actually look much more technologically like Temporal now, or Cadence, which is that they don't programmatically build DAGs, right? They just run code, and it's more like a distributed state machine. So you can write loops. It's more dynamic. It's more general purpose, more imperative. And I think like the concrete difference there appears very early in the product experience, where in Prefect, you can't visualize the DAG of compute until it starts running. Whereas in Airflow or Dagster, you know much more about the structure ahead of time. And then we at Dagster kind of went a different direction. Instead of going more imperative, went more declarative, right? And more specific, purpose built for the data platform use case with this kind of, it's actually returning to the roots of the project. I was just reviewing my initial deck from 2018, actually, but we went in this direction where you declare a graph of assets, right? And we try to kind of abstract away the execution on your behalf. And that places it sort of in the spectrum in between Airflow and DBT, right? Which is like declarative data assets, but only using Jinja templated SQL over a data warehouse. So, and I think it's actually a great development for the ecosystem that these systems have kind of put their stake in the ground, so to speak, and like, we believe this is the way these things can be organized, and it's given the customers, the community, a lot more choice. And I think we're exploring the solution space like very nicely. So I think that's been like a really interesting development over the last 5 years. I just talked forever, so please feel free to follow up on that.
No, I think that that's all very useful context and very accurate. And as you said, the next generation of orchestrators that have been introduced since that initial foray of Dagster and Prefect as a response to the pains that people are experiencing with Airflow are largely focused either on the ML use case, or we just want everything to be cloud native, whatever that might mean, which largely just means we rely on Kubernetes as the core engine of what we are doing. And we're largely bringing data awareness to Kubernetes as an orchestrator. So I'm thinking in particular of the flight project from Lyft, or there is the response of, we are going to be a vertically integrated solution so that orchestration is a component of it, but we want to own the entire lifecycle of your data, and we will be the ones responsible for actually managing the underlying compute, versus a Dagster or a Prefect or an Airflow that says, you own your compute, we're just here to help you tell it what to do.
Yeah, no, and I was remiss to not talk about Flight as well, which is a project I have a bunch of respect for, which is kind of, it's interesting. I would say almost they're like in this space in between being an Airflow successor and one of the ML ops platforms. I actually they very much target the ML orchestration use case, but in reality are quite a general purpose orchestrator. And so yeah, that's a good call out.
Going back to the question of adoption and the motivating factors for somebody to bring in an orchestrator into their stack, there's definitely an incremental cost. How large of an increment that is depends on what system you're using and what you already had in place and what you're trying to do with it. But what are some of the ways that you're thinking about the ways to mitigate that incremental cost and smooth the adoption curve, particularly when it comes to integration with that broader ecosystem? So you mentioned having a very good story for people using DBT, so the analysts don't have to be aware of everything that Dagster is doing. There are people who maybe already have some investment in Airflow, most likely because of its state as the incumbent. And then there's a whole host of other tools and new ones being added all the time. And if you're investing in an orchestrator, you want to make sure that it is going to work with everything that you need it to work with, preferably without having to do a whole bunch of re-engineering on your own to make that happen. So I'm wondering how you've been thinking about the motivators for adoption and ways to reduce the barrier to entry, particularly with the constant volatility of the overall ecosystem.
Yeah, one of the challenges of orchestration is that, you're really putting yourself at the center of the storm, so to speak, on a few different dimensions, both how you deploy to all the heterogeneous infrastructure at companies. So there's that aspect. And then there's also what you talked about, which is integrating with the rest of the data tools where people are actually crafting their computations. And they're kind of two separate questions. I think one, we've really tried to meet users where they are on the infrastructure piece by having both the option to, our commercial product Dagster Cloud has both a serverless component, or a serverless variant where we literally host all the computation. And for a bunch of users, that works really well for them, especially if all they're doing is orchestrating other SaaS services and they don't need to manage, if all their compute is managed anyway, like there's no care really if the orchestration compute is on-prem versus not. And then then we also have this hybrid solution where, we host the control plane and the metadata store, and people can run their compute and keep their data in their VPC or on-prem. And they end up running a fairly simple cluster. I like to call a stateless cluster. All it does is you spin up one unit of compute for a run, it runs until it's complete, and then it spins back down. So that ends up being a pretty simple model infrastructure-wise. And I think helping out users with that is, just really doing a bunch of blocking and tackling on the quality of our integrations. And then importantly, always having ways when a user reaches the edge of what is reasonable for us to generalize, allowing them to kind of punch down in the abstraction layer and add their customization, because just software systems requirements are so different depending on the domain of the business. So, we've really tried to minimize the infrastructure overhead as much as possible and really make it effortless to run the compute. Then there's the other aspect you're talking about, which is all the different integrations you have to deal with. And that's also a challenge too. I think that we have done a ton of work building up an integration library. We also have an active community that has submitted tons of integrations. And I'd love to see us kind of continue to mature and expand that, especially with getting more community involvement. Yeah, did you want to follow up on any particular aspect of that?
I think that the integration piece is, at least personally, where a lot of my interest lies. And I realize I probably should have called out earlier in the conversation my personal bias as a user of Dagster, but anybody who's been listening to the show long enough already knows that. So in particular, as you said, you do have a good suite of pre-existing integrations. You have a very good set of abstractions and framework layers that people can hook into to add their own behavior and integration with other systems. There's also the question of how much does that integration need to do for the user versus it just being a hook into another system that you then have to add some glue code to manage. So for instance, for the Airbyte and DBT use case that's gaining a lot of popularity, you have a good answer where you can automatically introspect the set of connections in Airbyte, the tables that will generate, and you can easily wire that to the set of inputs that the DBT models are expecting, and you can generate this full asset graph with a few lines of code. I think I've got it in something on the order of like 15 or 20 lines of code in my project. Whereas there are other integrations, thinking in terms of something like AWS, where the integration largely just looks like, we will pre-populate the S3 client for you, the rest is up to you, we don't have any opinions, which is definitely great. It's useful having that layer of fundamental connection, but then there are also questions of, for the people who you're trying to target, how much handholding do they need? Do they just want to be able to snap together some Lego bricks and not have to worry about the mechanics, or do they need to be intricately aware of what is being done and have full control over that execution? And how do you balance those levels of completeness for those integrations?
The answer is people always want both because we can't predict all the upfront needs. A lot of it is a reflection of the properties of the target systems as well, right? The way I think about it is that, what does it even mean to have an integration with S3 that would get as much information as the information with Airbyte, right? If someone has encoded a bunch of knowledge in their Airbyte installation they've set up sources, right? They've set up all this configuration. There's all this state that lives in their Airbyte install. And what Dagster is doing with our integrations is we're saying like, hey, you've done all this work to kind of configure your data assets in this system. Instead of making you do it twice, we're instead going to reach in and grab that information out so you don't have to, so there's a source of truth somewhere. And similar with DBT, similar with, high touch, all of our integrations with kind of higher level SaaS tools. In something like S3, no one is encoding that level of information there, right? So we kind of try to maximize the amount of we try to keep it dry, don't repeat yourself in that way whatsoever. And I think, we can't cover every single system for all time, but for example, this is where the open source aspect really comes into play. There's a DBT-esque system called Dataform, which was acquired by Google, if memory serves. And one of our commercial customers was kind of a legacy data form user, and they wanted to have a similar capability as the DBT integration. And we're like, listen, we can't build and maintain that integration ourselves. It's not widespread enough, but look, we can work with you and you can kind of ape or copy the integration that we wrote with DBT for your own purposes. And they're like, okay, we're totally willing to do that. And that was like a great example of, we have this existing integration. The customer understood and they were totally reasonable. They're like, yeah, why would you maintain a super mature integration for kind of a more niche system? But we gave them the tools so that they could, replicate that experience in their own infrastructure. And I think that's like one of the powers of having one of these open systems.
Absolutely. Yeah. Other examples that I've come across in recent memory in my own work of that balance of having enough information to be able to build your own integrations and enough pre-existing infrastructure to make it relatively simple are the work on the open metadata project, where they actually, as part of their default install, will embed Airflow as their kind of scheduling system for being able to pull in the different sources of metadata. They've recently added an interface to be able to make that agnostic to whatever orchestrator you want. And then in that DBT story of DBT versus Dataform, the newest challenger is SQL Mesh, or one of the newest challengers, which at least looks compelling. So there's also that aspect.
What aspect of SQL Mesh do you find most compelling? I'm not to. I'll be the interviewer. I'm very curious about your take on this.
I think the most interesting aspect of SQL Mesh is that they are trying to have a native understanding of the SQL semantics versus DBT, which is very focused on, we just want to be able to wire together all these SQL blobs for you. We'll add some templating, but it doesn't actually understand the SQL, whereas SQL Mesh is trying to go at a deeper level of wiring together the different blobs of SQL by understanding, okay, this generates this table, this uses this table, but only these 3 columns, and so we're actually going to automatically generate column level lineage because we know what's happening, versus DBT of, we're going to make you do the wiring together by using these different Jinja macros, and we'll use that to be able to wire things together. But other than that, we don't actually know what's happening.
So you think the big difference is that SQL Mesh is aware of the SQL AST and can therefore understand native column level lineage, whereas DBT is more kind of smashing together strings with Jinja templates. Therefore, it doesn't have deep understanding of the SQL. Got it.
Exactly. And also, because SQL Mesh has that AST level understanding, it's able to do automatic translation between different SQL dialects. So if you write your code for DuckDB, but you want to deploy to Snowflake, they'll actually do that translation for you.
Very interesting.
It's always fun to have these little forays into side channels. And another aspect that I wanted to touch on is the visibility that the core orchestrator has into the overall system, the ways that that authority is challenged, not in terms of different orchestration competitors, but just in terms of trying to run the system. You mentioned, for instance, temporal. Airbyte uses that internally for their scheduling and execution. I mentioned open metadata that wants to embed Airflow as part of their system. You mentioned that DBT Cloud has its orchestration capabilities that they want to control so that they know what's happening in the system. And then from the organizational level, there's the aspect of developers want to be able to get things done. And if they're writing DBT code, maybe they just run the build from their laptop, and then Dagster has no visibility into the fact that that happened without you adding a little bit of extra work around that. And I'm wondering, what are some of the ways that you think about incentivizing everyone to use that central orchestrator as the means of actually driving computation versus all of these other competing interests that want to own their piece of the puzzle and then having to retroactively recreate a visibility of that overall state?
Yeah, I guess when I think about it from 2 dimensions. And in the situation you're talking about, I am usually thinking about in terms of, there's a centralized data platform team, someone who's owning orchestration, who is responsible for the general health of the overall data platform, and then the stakeholder teams. What we find is that the earlier a stakeholder team can kind of plug into our asset graph, that lineage graph, and they can see visually both their own assets as well as the way they interrelate to the other teams, that's an immediate unlock in terms of the value of the system. They can now place themselves into kind of context in the rest of the org. And then the other thing is, generally, if the data platform team is doing a good job and we hope that Dagster can help with that. They provide a very clear incentive structure for the stakeholder teams to kind of onboard onto the more centralized platform. So generally that involves a much smoother development workflow. So the ability for all the stakeholders to use like the branch deployments feature in Dagster Cloud, which is, creates a lightweight staging environment with every PR, which people instinctively understand that's very valuable. And then typically there's also some sort of contract where between the platform team and the stakeholder team where it makes it much easier for those stakeholder teams to self-serve their pipelines operationally with higher quality tools. And that's where kind of being able to use this centralized UI where your data platform comes alive and you can kind of understand what's going on and build alerting on it. So I think there's both this like, what's the immediate value that we provide to the stakeholders? And then also like, what's the exchange of value that's been set up between the platform team and the stakeholder teams?
This episode is brought to you by Datafold, a testing automation platform for data engineers that finds data quality issues before the code and data are deployed to production. Datafold leverages data diffing to compare production and development environments and column-level lineage to show you the exact impact of every code change on data, metrics, and BI tools, keeping your team productive and stakeholders happy. Datafold integrates with dbt, the modern data stack, and seamlessly plugs in your data CI for team-wide and automated testing. If you are migrating to a modern data stack, Datafold can also help you automate data and code validation to speed up the migration. Learn more about Datafold by visiting dataengineeringpodcast.com/Datafold today. One of the other things that has been gaining a lot of ground, particularly in the past 2 to 3 years, in the overall space of data work is the idea of low code or no code, so that it's easier for non-engineering teams to self-serve into that data workflow or be able to build some of their own workflows without having to bring an engineer into the picture and be blocked by whatever their availability happens to be. And I'm curious whether you see that low code, no code interface as the responsibility of the orchestration layer or as a utility that plugs into the orchestrator or that the orchestrator federates out to for managing those execution graphs.
So it's a good question. So I would say 90% of the time, I'm pretty skeptical of low code, no code solutions in that I think they fall over and break when pushed, and therefore you fall back to code anyway, or you're left with this completely unobservable, undebuggable mess. I didn't say 100% though. And I do think and I'm looking forward to future directions in the Dagster ecosystem where there are low code, no code solutions. But to me, in order for them to work well, two things have to be true. One is that you still have to be incorporated into a software engineering process, meaning that if the user makes a change to their data pipeline using the no code tool, you need to be able to validate that things are working before you deploy it to production. And most of the no code tools don't do that, which is a big problem. Second of all, I think any low code, no code solution needs to be integrated into the platform. The important bit is like maybe that no code, low code solution can handle like the 90% of the nodes in a data pipeline. But then there's that critical 10% that are too bespoke and need too much customizable needs where you need code and you need the ability to kind of break the no code abstraction layer and have an engineer kind of take over this like particularly critical or custom, something that can't be encoded with a drag and drop tool. In that eventual future where there's a no code, low code tool that's incorporated into the software engineering process and more deeply incorporated into the data platform, to me, this orchestrator has to be at the heart of that and has to be, at minimum, very cognizant of these tools and integrated in a way or even built in natively. So that's kind of the way I think about it. But you can imagine right now with this branch deployment idea, which I think is very powerful, you branch your code and then it deploys a lightweight staging environment, which is every PR. You can imagine with a no-code tool, you could kind of be dragging and dropping a pipeline in a branch as well, and then have the same kind of, I'm branching this drag and drop pipeline, then like re-merging it. So you can operate in a branch, test it out, make sure it's working, and only then merge it back. but the no code tool would have to be deeply aware of the branch deployment abstraction underneath for all that to work. So I'm not ideologically opposed to no code tools. I just think they have to be incorporated into a software engineering process for something as high stakes as a data platform.
Absolutely. And that is something that I've been seeing as a general trend in recent years, is that awareness that low code is not the entire solution, and it can't be, because of the fact that it can be very brittle, and you do have to get down into the level of writing custom code for it to be able to power every use case. I think one of the interesting implementations I've seen of that is from the folks over at Prophecy, where they are a drag and drop UI of, we'll just give you your building blocks, you drag and drop them together, but it actually translates that into code that lives in a Git repo, and you're also able to define your own custom blocks writing code that people can then snap together as long as you know the interfaces, and they use a lot of compiler tricks to be able to translate between the two layers. They actually build on top of, I think, Airflow and Spark as their core infrastructure components that they target. I think the folks at Ascend.io are also doing something somewhat similar, where they, I think, have a low code aspect. I think that it is still textual, but they try to have some of that same pluggability of different connectors, but you can drop down into the layer of writing Spark itself as well. So yeah, I think it's an interesting evolution of the space, because I definitely have been in the earlier iterations of low code or no code tools, and having to say, oh, okay, well, if you want to write code, here's a little text box, good luck.
No. That's when you know you failed.
Absolutely.
Is the write Python in this text box and it will be fine. It's like, you're not going to be fine. It's not going to be okay. This is in your app, that box where you can write arbitrary Python and save it to a database somewhere, and then the system loads it for you. That is the box of death and pain. Like, please avoid that.
Yeah, I think a lot of the allergic reaction that folks have to low code and no code is the drag and drop tools of the early 2000s. In my experience, those were things like Microsoft SSIS or SQL Server Integration Studios, and I think it was something called Kettle from the Pentaho project. I think I started poking at those a couple of times and said, no way, I'm done.
Right.
All right. So for the conversation so far, we've largely been talking in the abstract about data orchestration without speaking specifically to what the purpose of the orchestration is. Generally, the assumption is around business analytics or business intelligence, but machine learning has been gaining a lot of ground, and then with the introduction of large language models as a consumer grade capability, the whole space has taken off like a rocket ship. And most of the time when you see people talking about machine learning, they're building their own machine learning orchestrator with the presumption that all of the data is already cleaned and prepped and ready to go. And there are entirely different machine learning stacks with feature platforms, testing and experimentation frameworks, etc. What have you seen as the ways that orchestration is integrating the two sides of data prep and data cleaning with the ML workflows? Are those two separate concerns and you just have a clean interface for the handoff, or is that something that needs to be a continuous flow owned and orchestrated from a single system?
So there was a great article that hit Hacker News, and I think it was titled ML Ops is 98% data engineering, or mostly data engineering. I don't know if the term 98 might have been in the body of the article. But anyway, I thought it was a great article and articulated, I think, better than we've been able to do what we think about this, which is that ML engineering is mostly data engineering with some additional capabilities you need layered on top. But the core activity of building an ML pipeline that ingests data, processes it, and then produces a model out of it, it's fundamentally the same exact thing about building a data pipeline where the end data asset is used for data analytics. Furthermore, generally, it is critical for the data scientist or ML engineer to have full control over a good chunk of the data processing, because so much of building the ML model is actually understanding the domain of your data. And the only way to do that is to actually be the one writing the pandas code or the SQL code or the Polaris code that is, mucking around with this and doing the data processing code. So that's kind of the way we look at it. We view Dagster as a data engineering tool, and there should be a common data engineering layer that spans multiple disciplines, because ML engineering is mostly data engineering. Analytics engineering is mostly data engineering. And data engineering is mostly data engineering. So we're in this weird space now where, if you go into ML, often there's this entire parallel universe of tools that's completely siloed. And we don't think that's the right configuration of the world. We think that ML ops should be a layer over a data engineering layer rather than an entire silo. And this has both organizational and technological benefits. If you use the same data engineering layer, you have a unified lineage graph that crosses all your different teams. That's great. And then your centralized data platform team can make all sorts of investments in that data engineering layer that benefits the ML team, not just your data teams. And we've seen a lot of organic behavior among our customer base with this because we haven't really pushed this too much in our public marketing, which I think is a mistake. I think we'll look forward to 2024 on that one. But I think 90% of our customers use us for analytics and ETL. That makes sense. And then 50% use us for ML and 40% for production use cases. And that adds up to well over 100%, which means that multi-use case is the norm. And what we find is that usually data platform teams bring us in for the analytics piece and driving that. And then it's kind of like, wait, we could also use this for ML because those are just pipelines written in Python. And this is a great tool for that. So we're seeing a lot of some organic behavior that matches kind of our ideological view of this. And I'm really excited for that direction going forward. But yeah, so to summarize, we think ML engineering is mostly data engineering, and you should have a common toolkit and this entire state of the universe where ML is its whole other universe is like not appropriate, not great for anyone actually.
And I think that also is an interesting view of the adoption curve paralleling the curve of data sophistication within an organization, where in the book from Joe Reese and Matt Housley, they talk about that idea of your kind of level of data maturity, where at the very beginning, you're just trying to figure out what data do I have? How do I even start working with it? To, okay, I've got a good handle on the core data needs of I have ETL pipelines, I can do the very basics with it, to okay, now I have data in a good place and I can start building more sophisticated usages of out of it. So I can start doing things like reverse ETL and operational analytics. I can start thinking about building things like recommender systems, and then to okay, now I can start doing proper data science and machine learning onto it. And having the orchestration engine be able to grow with you along that maturity curve is also a very valuable aspect of the consideration of what are the ways that you want to be able to manage your workflows that are related to data, whether that is I just need to know how to even start working with it, to everything is great and now I'm doing some really sophisticated stuff with it.
Yeah, that was extremely well said. You might have a future in product marketing, Tobias. That was great.
And so another aspect of the single pane of glass, full visibility into the overall stack, is that idea of lineage that you mentioned, where you want to make sure that everybody has the same view of how did I get to here and where did I come from to get there. I've asked you this in past interviews as well. I'm curious a little bit on whether your opinions have changed at all or whether there's more nuance that has been built up. But is the orchestration engine the right place to own all of that metadata? Or is it too much of an effort to try and bring all of that information into the orchestration system, and you actually do still need a separate metadata catalog or lineage graph to be able to get that complete, comprehensive, cross-cutting visibility of everything that's happening in your data suite using something like a data hub or an open metadata or one of the commercial offerings that are out there?
So I think that there is, first of all, I think it is totally appropriate and natural, intuitive for there to be built-in lineage and cataloging into the orchestrator. And I think anyone who uses an orchestrator that has that kind of can't go back. That being said, all those other products you mentioned, there's Data Hub, there's Atlan, there's all this other stuff, has a vast array of metadata capabilities. And they often speak of metadata activation, and they incorporate metadata into all sorts of business stakeholder facing workflows with like manual annotation and all sorts of processes that is more like a business app rather than a operations technical facing app. So I view Dagster's built-in lineage graph as a higher level of abstraction that those asset catalog vendors can build on. Actually, there's a previous episode, I think you called it like the future of data ops, and you were interviewing. It was a great episode, and it was actually the co-founder of Monte Carlo. I'm not recalling his name, but he kind of laid out like effectively the gold standard of data ops in his view is the global lineage graph where everything is alive and you can remediate issues directly within that graph. And he thought it was so awesome that if there was a world where all the tools didn't have to re-implement that from scratch, you know? And I was like, this is praise on, testify. I was very excited about that because that's effectively what our vision is for that, is that it makes sense for there to be a system of record that takes operational responsibility for all these assets. The integration is very clear, but we want it to be an open API where people can kind of build additional capabilities on top of that.
Yeah, Lior Gavish is the gentleman who you were trying to remember.
Yes.
And so now, having worked in this space and made a significant contribution in terms of the product that you've built in the form of Dagster and your experience of working with customers who are trying to fathom this space of data orchestration and how that will help them try to get a grasp on this volatile ecosystem of data engineering and data management, what are some of the most interesting or innovative or unexpected ways that you've seen data orchestration implemented or applied?
So it's been a theme we've talked about, but my mind always goes to these kind of data platform engineers who enable very interesting internal applications. So, for example, we work with an energy company where there's a data platform team that has built tools for their geologists. And they actually have kind of integrated Dagster. They have these custom tools where actually using a GUI, the geologist can configure runs they want to do. And it's extremely bespoke visualization of like depth of oil drill, oil wells and stuff like that. But then they press a button and then that actually kicks off runs in Dagster. And so they've kind of like integrated the two UIs and then also built their own framework on top of Dagster for those geologists to use. So it's just like this like very clever usage of the system that shows it's a platform for tool building in a domain that I wouldn't have guessed is applicable. And a similar story. There's another pharmaceutical research company that's a longtime Dagster Cloud user. It's kind of a similar case where they have built a layer of technology for their researchers to use. And then they've also figured it out. They've kind of wedged into our abstractions so that they can transparently move compute from one system to another to minimize cost without changing any of their business logic. And they have empowered their less technical stakeholders who are research scientists in order to do it. So those use cases where people are, really integrating Dagster into their production apps and their internal tools in a really fine-grained, interesting way, it's been super cool to watch. And it's happened more than once, which means it's not a fluke, which is sweet.
And in your work in this space, what are the most interesting or unexpected or challenging lessons that you've learned?
Oh, good Lord. And I think it's a classic thing when you build any startup or project, which is you're building a very generalized tool. People want to pull you in a bunch of different directions. They want every integration ever. I want to deploy on every infrastructure, integrate with every single system. And it's impossible for a small company to cover all the bases. So balancing this messaging and the technology such that the easy things are easy and the challenging things are possible is always a struggle. And you want to empower people, but also set expectations properly about the amount of work they have to do. So I think that has always been a challenge. And then combine that with the pace of change in the ecosystem, because everyone in the data ecosystem starts with point solutions and then they shape their product to the realities that they're seeing on the ground. Maybe they expand into adjacency. So it's this constant shifting of landscape. about who's doing what and what their focus is. So, and as the orchestrator, you are kind of at the center of this storm. So it's a very challenging engineering domain to work in, and you're faced with a ton of trade-offs all the time that don't make everyone happy all the time.
Yeah. And I was just realizing too that in all of our conversation about integrations, we were largely focused on integrations with other complete systems, but there are also the integrations with the underlying compute substrate that we completely failed to touch on, is probably a whole other conversation on its own. But just to quickly tick a few off, there's Kubernetes, Spark, Dask, Docker containers, Celery orchestrators. So
Yeah, ECS too.
yep.
Actually, I've ECS I feel is kind of a people don't appreciate how huge ECS is. It is used all over the place. Everyone kind of assumes that the default is Kubernetes, but we find for AWS users they default to ECS.
Yep. And so I think I know the answer to this, but for people who are just starting in this space, they're trying to comprehend what are the options out there, what are the ways that data orchestration fits into their stack, what are the cases where it's just the wrong choice and they're better off with just use cron.
Yeah, I think if you use a single tool and you're going to use a single tool for all of time, then bringing an orchestrator is probably too much, right? So if you literally just want to replicate data using a ETL tool like 500 terabyte and then directly query that data using a BI tool, probably overkill. If you're a small analytics engineering team, you're only going to use DBT, no other technologies, then a simple orchestrator is a solution for you. So those are the cases where I really think about it. Or if you're using a fully integrated like drag and drop solution where you don't need to bring an external orchestrator. But broadly, I think if you plan on using more than one technology and actively developing over time, then investing in an orchestrator makes a lot of sense, regardless of which one you choose.
Absolutely. And so as you continue to work in this space, iterate on your product, keep tabs on what the other players in the market are doing, what are some of the things you have planned for the near to medium term, or any useful thought exercises or evaluation criteria that you have for people who are just getting started in this space?
Yeah, in terms of what we're thinking about next, we actually, in the same way that we think that a data orchestrator should kind of have a cataloging capability in it, we also think that it's natural for the orchestrator to be involved in consumption and spend management as well as data quality. It's very natural for the orchestrator to have an opinion about consumption management because it is the thing that kicks off the compute that ends up draining spend. So if you can debug your pipelines and understand like what's causing you to why is my Snowflake bill $100,000 this month? We think the orchestrator can play a big part in both diagnosing that and preventing it in the future. And then, if our mission is to build a single pane of glass for the data platform, integrating data quality capabilities into that single pane of glass makes a lot of sense. You should be able to look at your asset graph and be like, oh, this passed all my data quality tests. There's a green dot. Great. And I should be able to alert off that. So you'll see us going into that direction and then really supercharging this kind of data platform stakeholder dynamic. We have a bunch of work to do there. So that's kind of what we're thinking in terms of our short to medium term roadmap.
Are there any other aspects of the overall space of data orchestration, the capabilities that it offers, ways that people should be thinking about it, or any pontifications about its future direction that we didn't discuss yet that you'd like to cover before we close out the show?
No, I think we're well over an hour, and so I'm sure that everyone could use a break from the data orchestration talk, and I think we've covered a lot of ground.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the usual final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I mean, it's always tough to ask this to a vendor because it's nearly impossible not to just, again, talk your own book.
Well, the idea is that as a vendor, you've already filled the gap that you saw, so you must have a new one.
The journey is never complete, Tobias. I guess to me, the biggest gap, or maybe the most interesting question that will be resolved next few years, is how the industry is going to solve this fragmentation problem. Like, I think everyone has vendor fatigue. Everyone understands that like you have to bring in too many point solutions to assemble a platform. And what is the shape of the solution to that going to be? Is it going to be like everyone bets on one vendor with complete vertical integration? or is it going to be makes it easier to horizontally integrate a bunch of vendors? I want them both for the sake of running the company as well as the way I like software to be configured in the world. I hope it's the horizontal version of that. And we feel it with building our own platform actually internally. It's just like you have to deal with a lot of moving pieces all the time. And I'm excited to hopefully participate in a solution where people feel like they have choice, but they can make choices and have the ease of use of an integrated solution. But I think that's kind of one of the fundamental questions that's going to play out over the next few years.
Absolutely. Well, thank you again, as usual, for taking the time today to join me, share your thoughts and perspective on the ecosystem of data orchestration, and making a best effort to have an unopinionated take on it. So appreciate the time and energy that you and your team are putting into making orchestration an easier and more interesting problem area to work in. And I hope you enjoy the rest of your day.
Yeah, and for the audience, by the way, I don't claim I was unbiased during the whole part, but during that section where you asked me to give me the state of orchestration, I did try to have an objective viewpoint. Thanks a lot, Tobias. It was great to be on the show.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.